So at this point, you know a lot about formulas, and formulas in chemistry are sort of like the words, and those sentences that contain the words are like the chemical reaction equations. And those equations need to have a certain grammar, which means that they must be balanced, which means basically the same number of atoms on each side. It's a real simple concept, not always easy to pull off. So I'm going to talk about strategies on how we can balance equations right now. Nanu, everybody. Mike here. Today we're going to talk about balancing equations, and let's just take a look at this one that I dreamed up here. What's going on here is what we call in science perversion, because this is not balanced. In other words, you can probably see that there's 4 carbons on the left and only 1 carbon on the right, which would mean that the universe would empty itself of carbons, and it would also fill up with oxygen. So that cannot happen. So here's how we deal with these. We want to think of there being a little space here. I'll put a little space where we are allowed to put numbers. We are not allowed to change any other numbers in the formulas because, as you know, formulas are there for a reason, and so I can't just fudge this whole thing by putting a 4 C4O2. Well, there is no C4O2. So you cannot change the little numbers. You can put big numbers to the left, and one of the sort of rules of thinking is that when you write a number to the left, you are multiplying that number through the formula. And so these numbers here are called coefficients, and coefficient. And you are allowed to put numbers there. And if there's no number there, that's considered to be a 1. Now, what my strategy is usually is you start with the more complex things and balance them. So the goal of this is to make there be equal number of carbons, hydrogens, and oxygens on each side. So there's only 3 elements to balance here, but usually you want to save something that is an element for the end, because if I put a coefficient here, it's only going to change the number of oxygens. But if I put a coefficient right here in front of this C4H10, which, by the way, this is butane. This is a legit reaction. When you go and light a candle, you probably take one of those sort of little lighters, and that's got butane in it, and then all this combustion makes CO2 and water. So we're not just making up stuff that doesn't exist. This happens. But when I put a coefficient here in front of the butane, that's going to change 2 variables at once. It's going to change the number of carbons and hydrogens. So you kind of use elements as your sort of get out of jail free card if you can. So the first thing I can do is I can say, well, I'm not going to touch oxygen right now, but I'm going to go fix either my carbon or my hydrogen problem. So I'm going to try to fix the carbon problem first. The problem is, if I were to count this up, I've got 4 carbons on the left and 1 carbon on the right. And so I could try to see if I get lucky by putting a 4 there. Now, when I put a 4 there, not only did I make it have 4 carbons on the right, but I also made this have 8 oxygens. So I helped jack up my oxygen even more, but we're going to get out of it later when we put a coefficient in front of O2. So now let's go try to tell me how many waters I should be able to have, or what the coefficient should be right there in order to fix and balance hydrogen. Did you say 5? Because if you did, you were right. And now, at this point, if I stop and count, I have 4 carbons on the left, 4 carbons on the right, 10 hydrogens on the left. Now watch out. This looks like 5 hydrogens, but there's H2, so it multiplies all the way through. And I've got 10 hydrogens on the right. And so carbon and hydrogen are balanced. But oxygen is all sorts of jacked up. And so what's going on here is this has 4 times 2 is 8 oxygens. This would be 5 oxygens, 13 oxygens. And now that's a bummer, because what happens is the oxygen is all goofed up, but I can't get 13 oxygens with an O2. And so the thing that you could do is just sort of go and put a 2 here now. So I'm going to write this over again, or it's going to drive people nuts. C4H10. And now what I could say is I'll do it all over again, but I'm going to now put a 2. And that's the thing, is you can screw up as much as you want, as long as you end up not having everything screwed up. And so I could say, well, what if I went ahead and put a 2 there? All right? And now you kind of already know what to do, because you know, okay, well, that's 8 carbons. And so if I could put a 8 in front of there, and you know if it was 5, so now it's a 10. And now you see what you have is 16 oxygens here, which is double what it was before. You have 10 times 1 is 10 oxygens, 26 oxygens. Now, be careful. I'll see my students put a 26 right there, and that would be the wrong thing, because you see O2 has 2 oxygens there. And so you really only need to have 26 oxygens, you need a 13. And so that is the balanced equation, and that equation is a proper way of writing that. Now, I'm going to tell you something else, and now some of you will like this and some of you will not. When it comes to diatomic compound or diatomic elements, or just in general, you're allowed to put a fraction, even though there's no such thing as 13 halves of an O2. You could put a fraction there. They do this with diatomic elements, and so this either way would be acceptable. Of course, I have nothing there. That's an understood 1. And what you should do is take inventory. So in each case, I should make sure, did I get everything right? And then you should do a count. I know it's boring, but you should probably count everything up and say, okay, what do I got here? I got 8 carbons. And over here, I got 8 carbons. That's balanced. For carbon, at least. I got 2 times 10 is 20 hydrogens. And I've got, now you get right here, 2 times 10, 20 hydrogens. We already figured out that our oxygen's balanced. 16 there, 10 there, 8 times 2, 16, 10 times 1, 26 oxygens, 13 times 2, 26 oxygens. And now you can move on from there in your life. And if you did this one up here, same kind of thinking, except we could do it with the different coefficients. It'd be 4 carbons, 4 carbons. We have 10 hydrogens. We got 10 hydrogens, and then we had 13 oxygens, and 13 halves times O2 is 13 oxygens. You pick whichever one you want. If you like whole numbers, you want to do what I did below. And especially if you don't like fractions. Trust me, people generally don't like fractions. In my experience, 7/8 of all people don't like fractions. And so if you want to go ahead and clear that fraction here, you go ahead and multiply everything by 2. And then you could leave it there with a fraction too. But that might kind of get you later when we talk about stoichiometry. Now folks, I'm kind of not very useful today, because the best way to learn balancing equations is to just practice a bunch and you just get good at it. But let's try another couple examples next. All right, here comes another one. And you see that we got 2 elements there. We got the lead and we got the oxygen. So you know what I'm going to do? I'm going to maybe hope to keep them later. Now, I'm going to be honest with you. I haven't done this one maybe ever or before. I just pulled it out of a book somewhere. But what I'm going to do is I'm going to go ahead and I'm going to save lead and oxygen till later and look at my other problems. I've got lead, I've got hydrogen, I've got oxygen. And now I've got more participants. I have 4 where the last example had, no, actually the last example had 4, but I got 3 on the left. so it's a little bit different. So I'm going to save my oxygen till later, and then what I'm going to see is that no matter what I do, I've got too many high oxygens on the left. Saving lead for later, but I'm going to end up changing it because there's no way I can balance oxygen without doing something over here. There's only 2 oxygens in a PbOH2. This is lead 2 hydroxide would be called, but I can't balance it with just 2 oxygens and 3 over there. So I'm going to go try to throw 2 in there and see if I get lucky. Frankly, sometimes you're just throwing numbers at things, like the next example we do. And I'm going to remember that I could always get out of jail for free with my oxygen, but I have to balance my hydrogens now. Well, actually, one thing I could do is try to save my lead till later. And let's look at our hydrogen situation. I've got, since I'm not going to use O2 later, I've got 2 times, now watch out, that parentheses means that there's 2 OHs. And so it's 2 times 2, I've got 4 hydrogens on the right, and I've got 2 on the left, so I'm going to slap a 2 there. Now I've got 2 elements left, and these are easy to get out because I got a problem with the leads. There's 2 on the right and 1 on the left. Let's go ahead and fix that. And let's see if I can fix my oxygen. Now watch out, oxygen is in 3 places here. So what I've got over here, and I might want to count them, 2 times O, and there's 2 each. 4 oxygens over here, and I got 2 oxygens right there. And so the thing to do is nothing with the oxygen, because I've got 2 oxygens and 2 water molecules, 2 is an O2, and so there's 2 oxygens there, and that is 4 oxygens. So I have balanced oxygen. I have 2 leads, and there's 2 leads. I have balanced lead. Just to double check now, I've got 4 hydrogens in the 2 water molecules, and then I've got 2 times 2 as we talked about before. So oxygen, lead, and hydrogen are all balanced, and it's game over. We have slayed that problem. Uh-oh. Uh-oh. Why am I saying uh-oh? I don't got an element. Now actually you'd be surprised. Sometimes the more complex the molecules become, the easier these things balance. And so, okay, I'm going to be honest with you, you just start throwing numbers at things, and it's a little trial and error. So one glaring thing is that titanium is balanced. Titanium 4 chloride, titanium 4 oxide, they're the names of these things. Titanium is balanced with 1 on each side. Maybe I can get away with not even touching that, but I don't know. I see that I have a glaring hydrogen problem. Now remember, it's not written in stone. You need to throw a number at it, and you could always, ungoof yourself up later. Now I've fixed my hydrogen problem. I've got 2 hydrogens on the left and 2 hydrogens on the right. But uh-oh, look what happened. I end up goofing up my chloride because that ain't gonna work. And it's okay. You just start throwing numbers. See, the chlorine I should say, there's 4 chlorines on the left and 4. So I'm gonna have to do something over here. We're gonna have to probably multiply another number. So I could put a 4 here. That fixes my chlorine problem. And it took me to have to mentally move towards chlorine later to see what was going on before I knew I needed a 4 there. And so, all right, now I've fixed my chlorine problem. There's 4 on each side, and I've totally jacked up my hydrogen, but I could put a 2 there. And now I can see if I got lucky, and you know what? I did. I got lucky. And sometimes these things, that the more complex the molecules are, the simpler the coefficients are. So when you have an oxygen in there, like the last one, we had 13 halves. Now we got a 1, a 2, and then, if you want to look all nice and tidy, you just write the thing over again instead of my scribble mark there. And then it's always prudent to check yourself before you wreck yourself to see if you really have everything balanced. So let's do that. Let's take one final inventory and see if I'm, it takes time and you feel like you did it right, but sometimes you'll catch yourself. I got 1 titanium, 1 titanium. balanced. Titanium is balanced. 4, and now watch out for things that appear in 2 places, but there's none of that going on here with this. 4 chlorines and 4 chlorines. 4 HCl's has 4 chlorines. 4 hydrogens and 4 hydrogens. Hydrogen is balanced. And 2 oxygens and 2 oxygens. So even though this had one more element than the last couple examples we did, this really kind of went out with a whimper. Once you start throwing numbers at it, yeah, I did get a little confused with my HCl. I put a 2 there to fix a hydrogen problem, but I was really also not fixing a chlorine problem. And so sometimes you got to bounce back and forth between what's on the left on the reactants and what's on the right on the products. So my best advice to you is to go pick 14 more of them and practice the dickens out of it. All right, short one today, folks, because a lot of it is on you practicing. But next time we're going to talk about every single type of reaction in the universe, the next 3 times, actually. So till then, see you later. Nanu Nanu. That's from a show called Mork from Ork when I was a kid. Yeah, you can go Google it, you young folks. Bye.